This is SpaceTime Series 29, Episode 55, for broadcast on the 8th of May 2026. Coming up on SpaceTime, scientists finally determined the cause of Venus's enigmatic lower haze, discovery of two worlds colliding, and confirmation that the Lunar Gateway space station modules are rusting. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have finally determined that cosmic dust is the source of a mysterious lower atmospheric haze that blankets the planet Venus. Venus is often called Earth's sister planet. Both are about the same size and were formed in the same part of the solar system under similar conditions and using the same basic materials. But if Venus is Earth's sister planet, then it's a twisted sister, with surface pressures 100 times that of sea level on Earth, and surface temperatures of over 460 degrees Celsius, hot enough to melt lead. Venus is shrouded by dense sulfuric acid clouds. It does rain on Venus, but instead of water, it's acid rain. And it even snows on Venusian mountains, but the snow is metallic. Even stranger, Venus rotates backwards compared to most of the other planets in our solar system, with the sun rising in the west and setting in the east. And it spins so slowly that a day on Venus lasts longer than its year. While the planet's main cloud cover sits between 47 and 70 kilometers above the surface, scientists have long been puzzled by a mysterious layer of particles below 47 kilometers, which they call the lower haze. First detected by spacecraft back in the 1970s, the origin of this haze has remained an unexplained mystery for more than half a century. But now, astronomers think they've finally solved the mystery, showing that this lower haze is formed by cosmic dust, tiny particles left behind by meteoroids which are constantly raining down on Venus. One of the study's authors, Hiroki Kayu from the Royal Belgian Institute of Aeronomy, says while the cosmic dust might seem insignificant, it turns out to be the missing ingredient needed to explain Venus's lower haze. The findings, reported in the journal Nature Astronomy, are based on computer simulations which were used to trace the life cycle of these particles, finding that incoming cosmic dust burns up high in the atmosphere, producing nanometer-sized mineral grains. These particles then become embedded within Venus's sulfuric acid clouds. As they drift downwards towards hotter and hotter atmospheric temperatures, the sulfuric acid evaporates, leaving behind solid mineral cores. These cores then collide and stick together, forming the haze layer observed by past missions. The computer model results closely match measurements collected decades ago, lending strong support to the author's conclusions. Kayu and colleagues also found that these cosmic particles play an important role in Venus's climate. Acting as seeds for cloud formation, they increase cloud production by an estimated 20 to 30%. These findings show that material from space isn't just a passive visitor, but can actively shape a planet's atmosphere and climate. The study reshapes how scientists think about planetary atmospheres, suggesting that similar processes may be occurring on the gas giants like Jupiter and Saturn. The authors now hope to test their predictions with future missions, including NASA's Da Vinci mission to Venus, which is slated for launch later this decade. This is SpaceTime. Still to come, discovery of two worlds colliding, and confirmation that the Lunar Gateway space station modules are rusting away. All that and more still to come on SpaceTime. Astronomers have found evidence of two planets colliding in a distant star system. The discovery, reported in the astrophysical journal Letters, are based on observations of a stable main-sequence sun-like star catalogued as Gaia 20 EHK, located some 11,000 light-years away in the constellation Puppis. The study's lead author, Andy Tsanodakis from the University of Washington, was combing through archival telescope data when he found the otherwise boring star acting rather strangely. It seems the star's light output was nice and flat for a while, but starting in around 2016, it began showing a series of dips in brightness. Sanadakis says it then went completely bonkers in 2021. Now, the cause of the flickering had nothing to do with the star itself. It seems huge quantities of rocks and dust, seemingly out of nowhere, were passing in front of the star as the material orbited in the system, dimming the light before it reached the Earth. Now, the likely source of all this debris was even more remarkable: a catastrophic collision between two orbiting planets. Sanadakis says, amazingly, several different telescopes caught the impact in real time. And that's significant because there are only a few planetary collisions of any kind on record, and none bear so many similarities to the impact which created the Earth and Moon. Some 4.5 billion years ago, a Mars-sized planet which scientists called Theia slammed into the early proto-Earth. The impact turned both worlds into a molten magma ocean. That ball of molten material eventually solidified to form the planet Earth we know today, and some of the ejected debris from that impact, which had been sent into orbit around the planet, eventually coalesced to form the Moon. Sanadakis says if we can observe more moments like this elsewhere in the galaxy, it'll teach astronomers a lot about the formation of our own planet. We know planets form in protoplanetary disks around stars. Gravity forces dust, gas, ice and rocky debris together, a process called accretion. But early star systems are chaotic places, with planets routinely colliding and breaking apart or being flung out of their orbits through gravitational perturbations from other planets. Through this process, and over maybe 100 million years or so, planetary systems like ours eventually winnow their planets down and settle into an equilibrium. As common as these collisions probably are, observing one in a distant solar system requires a lot of patience and even more luck. You see, the orbits of the planets must put them in direct alignment between us and the star. That's so we can actually see the resulting debris obscuring some of the star's light. And the telltale flicker can then take years to play out. Astronomers are a patient lot. Sanadakis says Gaia 20 EHK's strange behaviour was perplexing, and so he and colleagues looked for infrared observations rather than just visible light. And the infrared curve was completely the opposite of what the visible light curve was showing. As the visible light began to flicker and dim, the infrared light spiked. It got brighter. And that suggested the material blocking the star's light must have been hot, so hot in fact it was glowing in the infrared. And of course a cataclysmic collision between planets would certainly produce enough heat to explain that infrared signature. And the right kind of collision would also explain the initial dips in light. You see, that would be caused by two planets spiralling closer and closer to each other before they eventually collided. Sanadakis says that at first they simply had a series of grazing impacts that wouldn't produce a lot of infrared energy. Then came the final catastrophic collision, and he says the infrared really ramped up. He says there are also other aspects which resembled the one which created the Earth-Moon system. The dust cloud orbiting Gaia 20 EHK is roughly 1 astronomical unit away from the host star, and that's the same distance the Earth is from the Sun. At that distance, material could eventually cool down enough to solidify into something similar to our own Earth-Moon system. But of course, that could take a few million more years. As I said, astronomers are a patient bunch. This is SpaceTime. Still to come, confirmation that the Lunar Gateway space station modules are slowly rusting away. And we explore the constellation Scorpius, the spectacular M6 and M7 open star clusters, and the Eta Acrids meteor shower produced by Halley's Comet in our May edition of Skywatch. NASA has confirmed that 2 of the habitation modules being built for the now postponed Lunar Gateway space station project are suffering from corrosion problems. The admission by NASA Administrator Jared Isaacman was made during a congressional hearing last week. The primary contractor for the Gateway Habitation and Logistics Outpost, or HALO module, Northrop Grumman, has now confirmed that there is an issue. And the European Space Agency, which is providing Gateway's other habitation module, the IHAB, has also acknowledged that corrosion has been observed in its module. The thing is, both pressure vessel structures for these two modules were manufactured by the Franco-Italian firm Thales Alenia Space. Now, Thales Alenia initially refused to comment, but 5 days after Isaacman's testimony, the company finally admitted that, there were problems, stating that a well-known metallurgical behaviour was found on the surface of the module, which will be fixed by the end of the third quarter of 2026. Now, presumably, well-known metallurgical behaviour is some sort of euphemism for corrosion, in other words, rust. The company went on to say that it's also teaming up with ESA to fix the IHAB module, which is still at the plant and, as we said, is suffering from the same problem. And it doesn't end there. It seems Axiom Space, which has also ordered a pressurized structure for its private space station from Thales, says similar issues have been identified with the module for its future commercial space station. Initial analysis points to problems with the manufacturing processes, surface treatments, and material properties. The corrosion issues with the modules were a well-kept secret until Isaacman disclosed them during the hearings. Now, with the demise of the Lunar Gateway space station, Northrop Grumman has been trying to position the HALO module as an option for future lunar surface habitat as part of NASA's moon-based South Pole project. And ESA is likely to make a similar suggestion for its IHAB module. During his testimony, Isaacman said the corrosion issues were among other problems likely to have delayed the launch of the Lunar Gateway space station to well beyond 2030. Gateway was slated to be in orbit by 2028. Isaacman says he's not sure whether efforts to repair HALO and IHAB are even warranted at this point. Only time will tell what happens in the future. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for the month of May on Skywatch. May is the 5th month of the year in both the Julian and Gregorian calendars. The month was named for the Greek goddess Maya, who was identified with the Roman-era goddess of fertility Bonadia, whose festival was held in May. But I guess more importantly for many of our listeners, May typically marks the start of summer vacation season in the United States and Canada. Let's start our tour of the night skies by looking east, where you'll see the constellation Scorpius the Scorpion. In Greek mythology, the constellation was named after Scorpius, who was sent to Earth by the goddess Gaia in order to slay Orion the Hunter, after he boasted that he could kill all the animals on Earth. Scorpius stung Orion in the shoulder, but Orion's life was spared by Ophiuchus the Healer, and was placed in the heavens along with Scorpius, who continues to pursue him for eternity. Orion the Hunter has become the hunted forever, with Scorpius rising in the east this time of year to triumphantly chase and defeat Orion, who sets in the west. Meanwhile, Ophiuchus the Healer rises in the east following behind Scorpius to chase and crush him into the earth as the Scorpion sets in the west. And so, this ancient story continues to play out in the heavens year after year. Interestingly, parts of this story predate the Greeks, with Orion known in ancient Egypt as Osiris, the god of the underworld and of regeneration. The brightest star in Scorpius is Alpha Scorpii or Antares, the scorpion's heart. In ancient Greek, Antares means the equal or rival of Mars, the god of war. That's because its golden orange appearance is very similar to that of the red planet, and it passes very close to Mars every 780 days. Easily seen with the unaided eye, Antares is some 550 light-years away. But it looks so bright because it's around 57,500 times as luminous as the Sun, and is one of the largest known stars in the universe. Antares is a red supergiant, about 18 times the mass and 883 times the diameter of the Sun. Were it placed where the Sun is in our solar system, it would engulf all the terrestrial planets, Mercury, Venus, Earth and Mars, and its visible surface would extend almost as far out as Jupiter. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Astronomers believe Antares began life around 12 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectrotype O blue stars. They're followed by spectrotype B blue-white stars, then spectrotype A white stars, spectrotype F whitish-yellow stars, spectrotype G yellow stars, that's where our sun fits in. Then there's spectrotype K orange stars, and the coolest and least massive stars are known as spectrotype M red stars. Each spectral classification system can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So put it all together and you can describe our Sun as being a G2V or G25 yellow dwarf star, one of millions spread across our galaxy. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectrotype M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectrotype M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Like the similar-sized red giant Betelgeuse in the constellation Orion, Antares will almost certainly end its life as a spectacular Type 2 or core collapse supernova, probably sometime within the next 100,000 years or so. When it does explode, it'll appear as bright as the full moon for several months on end, and will be clearly visible during daylight hours here on Earth. Antares has a companion star, Antares B, located between 224 and 529 astronomical units away from the primary. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometres or 8.3 light minutes. Spectral analysis of Antares B indicates it's pulling a lot of material off its bloated red supergiant companion. Located near Antares is the M4 globular cluster. Globular clusters are tight balls densely packed with thousands to millions of stars, which were either all originally formed at the same time from the collapse of the same molecular gas and dust cloud, or alternatively their galactic centres, the remains of ancient galaxies that have been merged into the Milky Way galaxy over billions of years. M4 is composed of a million or so stars originally born some 12 billion years ago. The M4 globular cluster is located some 7,200 light-years away, making it one of the nearest globular clusters to Earth. Easily seen through a pair of small binoculars, it covers an area of the sky as seen from Earth as big as the full moon. Astronomers estimate there are some 150 or so globular clusters orbiting in the halo of the Milky Way. Located near the tail of the Scorpion are two open star clusters known as M6 and M7. Open star clusters are loosely bound groups of a few thousand stars, which were all originally formed from the same molecular gas and dust cloud at the same time, but are not as densely bound as globular clusters. Open clusters generally survive for a few 100 million years, with the most massive ones surviving for maybe a few billion years. Now, in contrast, the far more massive globular clusters exert far stronger gravitational attraction on their members, which is why they can survive so much longer. M6, which is also known as the butterfly cluster, is some 12 light-years across and located about 1,600 light-years away. It contains around 80 stars, which are all less than 100 million years old, which is quite young in cosmic terms. The M7 or Ptolemy cluster is named after the famous Greek astronomer and mathematician Claudius Ptolemy. It's about 980 light-years away and is far more dispersed than M6, covering an area around 25 light-years across. And at around 200 million years, it's about twice as old. By the way, the M in terms like M4, M6 and M7 are abbreviations for Messier, in honour of the 18th century French astronomer Charles Messier, who developed an astronomical catalogue of fuzzy nebulous objects in the skies. See, Messier was a comet hunter, and he compiled a list of 103 fuzzy objects which weren't comets, and so from his perspective could be ignored. Later, other astronomers added additional celestial objects to the list, bringing the present catalogue up to 110. Our solar system, in fact most of the stars we see when we look up in the night sky, are located in the Milky Way galaxy's Orion arm. The Orion Arm, also known as the Orion Spur or the Orion Cygnus Arm, depending on which name you prefer, is some 3,500 light-years wide and around 10,000 light-years long. The Orion Arm is named after the Orion constellation, which is one of the most prominent constellations in the Southern Hemisphere summer and Northern Hemisphere winter. Some of the brightest and most famous celestial objects in the constellation include Betelgeuse, Rigel, the stars of the Orion Belt, and the Orion Nebula, all located within the Orion Arm. The Orion Arm is located between the Carina-Sagittarius Arm, which is more towards the galactic center from our position, and the Perseus Arm, which is more towards the outer edge of the galaxy from our point of view. The Perseus Arm is one of the two major arms of the Milky Way, the other being the Scutum Centaurus Arm. Long thought of as a minor structure, a spur if you will, between the two longer adjacent arms, Perseus and Carina-Sagittarius, evidence was presented in mid-2013 that the Orion Arm might actually be a branch of the Perseus Arm, or possibly a completely independent arm segment itself. Within the Orion Arm, our solar system, the Sun, the Earth, and all the other planets we know are located close to the inner rim in what's known as the local bubble, about halfway along the Orion Arm's length, approximately 26,000 light-years from the galactic center. The local bubble is a cavity in the interstellar medium in the Orion Arm, containing among other things the local interstellar cloud which contains our solar system and the G-cloud. It's at least 300 light-years across, and it has a neutral hydrogen density of just 0.05 atoms per cubic centimetre. That's just 1/10 of the average for the interstellar medium across the Milky Way, and about 1/6 that of the local interstellar cloud. The hot diffuse gas in the local bubble emits X-rays and is the result of a supernova that exploded sometime during the past 10 to 20 million years. It was once thought that the most likely candidate for the remains of this supernova was Geminga, a pulsar in the constellation Gemini. However, later it was suggested that multiple supernovae in a subgroup B1 of the Pleiades moving group was more likely responsible, becoming a remnant supershell. Our solar system has been travelling through this region of space occupied by the local bubble for the last 5 to 10 million years. Its current location is in what's known as the local interstellar cloud, a minor region of slightly denser material within the bubble. The cloud formed when the local bubble and another bubble called the Loop 1 bubble met. Gas within the local interstellar cloud has a density of about 0.3 atoms per cubic centimetre. From what we can tell, the local bubble isn't spherical, but seems to be narrower in the galactic plane, becoming somewhat egg-shaped or elliptical, and may even become wider above and below the galactic plane, becoming shaped more like an hourglass. And it's not alone, it's abutting other bubbles of lesser dense interstellar medium, including the Loop 1 bubble. The Loop 1 bubble was created by supernovae and stellar winds in the Scorpius-Centaurus Association some 500 light-years from the Sun. The Loop 1 bubble also contains the star Antares that we spoke about earlier. Astronomers have identified several, well, I guess you'd call them tunnels, which connect the cavities of the local bubble with that of the Loop 1 bubble. Collectively, they've been referred to as the Lupus Tunnel. Other bubbles which are adjacent to our local bubble are known as the Loop 2 bubble and the Loop 3 bubble. Looks like astronomers still have a problem when it comes to thinking up cool names. Also visible this month is the Eta Aquarids meteor shower, which is generated as the Earth passes through the dust and debris trail left behind by Halley's Comet. Comet P1 Halley is a well-known short-period comet which visits the inner solar system every 75 to 76 years. The 15-kilometre wide mountain of rock and ice will make its next close-up appearance in 2061. It's named in honour of the British astronomer Edmund Halley, who in 1705, after examining ancient Chinese, Babylonian and medieval European records, successfully predicted its return in 1758. However, he died in 1742, before his prediction could be confirmed. The comet's highly elliptical and elongated orbit takes it from between the orbits of Mercury and Venus out almost as far as the orbit of Pluto. Halley's orbit is in retrograde, meaning it orbits the Sun in the opposite direction to the planets, that is, clockwise from above the Sun's northern pole. This retrograde orbit results in it having one of the highest velocities relative to the Earth of any object in the solar system, travelling at some 70.56 kilometres per second, or if you prefer, 254,016 kilometres per hour. As well as the Eta Aquarids meteor shower every May, Halley's Comet also produces the Orionids meteor shower in late October. Astronomers think Comet Halley was originally a long-period comet, which took thousands of years to travel to the inner solar system from the Oort cloud, but was gravitationally perturbed into its current orbit by close encounters with the giant outer planets. The Oort cloud is a hypothetical sphere of comets and asteroids beyond the heliosphere, a mixture of vagabonds from the solar system and objects from deep space which have been collected by the Sun's gravitational pull. Occasionally, as the Sun passes by another star, an Oort cloud object will get perturbed and be flung towards the inner solar system. The Eta Aquarids meteor shower runs from the 19th of April through to the 28th of May, peaking around May the 5th, with around 55 meteors an hour, making it one of the Southern Hemisphere's best celestial showers. However, back in 1975, they were running 95 meteors an hour, and in 1980 it was up to 110. Even better, the bright yellow meteors often appear as streaks known as trains. As their name suggests, they radiate out from the direction of the constellation Aquarius and the star Eta Aquarii. Just look towards the east after midnight and before dawn for the best view. And joining us now for the rest of our tour of the May night skies is senior science writer and Sky and Telescope magazine contributor Jonathan Nally.
G'day, Stuart. Yeah, well, what's in the night sky for May? Well, it's now autumn for those of us in the southern hemisphere, and it's springtime, of course, for our friends north of the equator. For us, where I live down south, that means the nights are becoming colder, but the hours of darkness are growing longer. So we've got more time for stargazing, which is good. Weather permitting, of course, because it's heading towards winter and weather gets in the way. But anyway, we have more hours of nighttime. Now, stargazers in each of the northern or southern hemispheres, they do have some constellations that only they can see. So up in the northern hemisphere, I've never seen the constellation of Cassiopeia and those sorts of ones. I don't think I've ever seen Ursa Major, Ursa Minor, those sort of ones. In the south, we've got constellations that people far in the north don't see. We've got the famous Southern Cross, for instance, which in the middle part of May evenings is standing upright and high in the south for once. These constellations, their appearance in the sky, where they appear in the sky depends on the time of the year as the Earth goes around in its orbit. So for a certain time of the year, a lot of people can't find the Southern Cross, and that's because you can't see it. It's below the horizon or very low down on the horizon. As the months go past, however, the sky has appeared to rotate a bit, and we get to May, and so we can see the Southern Cross now well above the horizon, nice and high, and standing straight upright as a kite shape. It's shaped like a kite, rather than lying on its left-hand side or its right-hand side as it does at other times of the year. To the left of the Southern Cross, we've got two bright stars in the constellation Centaurus, the two brightest ones, in fact, Alpha and Beta Centauri, and these are called the two pointers because if you draw a line between them and keep the line going, it points more or less towards the Southern Cross. I don't know why you need to do that. The Southern Cross is pretty prominent, although having said that, it is quite small, and there are a couple of other larger crosses not too far away that people do sometimes
I must admit,
confused.
I use the pointers to guide me to the Southern Cross, even though I know what the Southern Cross looks like and I know where it is in the sky. I'd still use those pointers, yeah.
If you see the pointers, you definitely know you're in the right part of the sky because the pointers are not near those other two large crosses, the false cross, and I can't remember the name of the other cross, but the false cross is really quite big because people think the Southern Cross must be really big because it's famous, but it's actually the smallest constellation in the sky. I don't really have any trouble finding the cross these days because I've been watching it for years and years and years, but when you're starting out, for sure, yeah, using the pointer stars to get you in the right area, in the right direction, is very, very handy. So they're on the left of the Southern Cross as it appears at this time of year. To the right of the cross are the constellations Carina, Vela, and Puppis. People probably never heard of those ones, Carina, Vela, and Puppis. And these ones, being more or less smack bang in the middle of the Milky Way, are full of wonderful star fields and nebulae. You can pick a lot of these out with just a small pair of binoculars. You don't need big binoculars, you don't need heavy binoculars, just a normal pair of binoculars, which is how I got going in stargazing eons ago. I had a pair of, actually it wasn't my pair, it was my mum's, it was a little pair of 8x30 binoculars. That's fairly small, and I could see stacks of things with those. I did have nice dark skies where I lived in a country town, much better than city stargazing, but you don't need a telescope to start with, just some binoculars, but if you do have a telescope, even a small one, you'll get an even better view of these star fields and nebulae and things. So grab a star chart or download an app for your mobile phone and see if you can find the star cluster called Omega Centauri. You can actually just make this out with the unaided eye. It looks like a tiny fuzzy star, but it's not a star. It's a huge globe called a globular star cluster of about 10 million stars, and it's about 17,000 light years away. But even a small telescope will show you that it's not a point of light like a star is. It's a round blob, a sort of faint greyish blob. And the bigger and bigger telescope that you use, if you can get your hands on them, you start to see more and more, and then you start to actually see stars in this huge star cluster, which is really quite incredible. And when you think it's 17,000 light years away, so what you're seeing now left there 17,000 years ago, it boggles the mind all the time. Another object you can try and spot, even with a small telescope, is a galaxy called NGC 5128, which is often called Centaurus A. There's a story behind that. I like to tell this story because if you look it up on Wikipedia, it'll say it's called Centaurus A, sometimes known as NGC 5128. When it was discovered, it was catalogued as NGC 5128. Centaurus A is the name given to the source of radio wave emission that is coming from this galaxy. When the first radio telescopes were being built, and the first ones down here in the southern hemisphere, they were pointing them around the sky, and they got this huge signal coming from this direction of the sky. When they looked, they saw, this enormous apparent origin of radio waves seems to be inside this galaxy called NGC 5128. So NGC 5128 is the name of the galaxy. Centaurus A is the name of the radio source coming from it that is inside the galaxy. But it's a losing battle. I've sort of given up. People call it Centaurus A or Cen A, and the NGC 5128 is the sort of secondary name given to it. But anyway, that's my little soapbox on that galaxy. It's about 10 to 13 million light years away. So when you're looking at it, think about that. The light that you're seeing now left there about 10 to 13 million years ago. It's got a massive black hole, and it's called about 55 million times the mass of our sun. Hugely massive black hole in the middle of this, they think. And if you see a picture, you can look it up on the internet, NGC 5128 or Centaurus A. You see that it's an odd-looking galaxy. It's got this big dark lane that goes through the middle of it. It appears to be twisted, and it's sort of appears to be a round galaxy rather than what they call an elliptical galaxy or a spiral galaxy. It's just, the angle that we're looking at it. But it's a bit of an oddball, but pretty specky. And the thing is, even with a small telescope, you can see this thing, and when you think that it's 10 to 13 million light years away, that's pretty impressive, I think. So what else we got? In the western part of the sky, just after sunset, you'll see the constellation Orion, the Hunter, which is dipping below the horizon this time of year. You've also got Sirius, which is the brightest star in the night sky, and it's the brightest star in the constellation Canis Major, or the Greater Dog. And a little bit to the north is another fairly bright star called Procyon, which is the brightest star in Canis Minor, or the lesser or smaller dog. Imaginative, aren't they, these names? Take a look at Orion and Sirius and Procyon now, because as the weeks go by now, they'll soon be out of sight. They'll dip below the horizon, and they won't appear again until the end of the year. For us in the south, the northern half of the sky doesn't seem to have much going for it at the moment. Now, not many bright star fields this time of year, at least during the evening time. There are some famous constellations there, though. You can see Leo, you can see Cancer and Virgo. Everyone's heard of those. They're some of the constellations of the zodiac. Virgo, in fact, is actually of great interest to amateur astronomers because it contains hundreds and hundreds of galaxies, which are really great to see, but you do need a telescope to see those, and some dark skies as well. If you're still out stargazing around midnight, you'll start to see some mighty impressive constellations starting to climb up over the eastern horizon. You've got the famous Sagittarius and Scorpius. Again, people have heard of those. And there's a couple of lesser-known ones called Scutum and Ophiuchus. And the Milky Way region through these constellations, all of those ones I just mentioned, is really quite spectacular. It's full of incredible star fields and star clusters and nebulae. Just a pair of binoculars will get you going there, and if you can get hold of a telescope to have a look, even better. And the thing is, when you're looking at Sagittarius, or at least the right part of Sagittarius, you are looking right into the centre of our Milky Way galaxy, which is why that area of the sky is pretty impressive, because, we're sort of towards the outskirts of the Milky Way, so when you look towards the centre, you're looking in towards the main part of the galaxy, so that's why there's so much stuff there to see. Now, let's see what's happening with the planets during May. Well, low in the northwestern sky, you'll find Venus after sunset. It's going to be there all month, slowly moving northward as each night goes past, but otherwise appearing fairly unchanging. And it's big and bright. It's much brighter than that star Sirius, which I mentioned earlier, the brightest star in the night sky. So Venus is really bright. You really can't miss it. Also in the northwest and a bit higher up is Jupiter. It's currently about the same brightness as that star Sirius, but it has a slightly off-white colouring. Sirius looks really searingly white, bright white, but Jupiter has a bit of colour to it. You might say it's a bit yellowish or orangish, something like that. As the month goes on, Jupiter's actually going to slowly start to sink toward the horizon. It'll still be above the horizon at the end of the month. And next month, actually coming up on the 9th and 10th of June, Venus and Jupiter will be quite close to each other in the sky, less than 4 moon widths apart. So these two big bright planets will be fairly close to each other, and that should look pretty specky. For our listeners overseas, specky is Australian lingo for spectacular. Should add that in. And lastly, we've got in the early morning sky, so if you're up before dawn, you'll find Saturn. And now it's rising above the eastern horizon about 4 a.m., followed roughly an hour later by Mars. As the month goes on, Saturn will be rising increasingly earlier, and therefore it'll be higher and higher in the sky before the dawn comes. So if you go out at 5 o'clock in the morning at the beginning of the month, you'll see Saturn at a certain height above the horizon, or altitude, I should say, and then like 3 weeks later, you go at the same time, you'll see that Saturn is now much higher in the sky. That's just due to the changing angles between Earth and its orbit and Saturn and its orbit, just a line of sight effect. Mars won't change much during May. It'll be sort of more or less hugging the horizon, about 8 to 10 degrees above the horizon all month, and it looks like a small reddish, orangish, medium brightness star. So as long as you've got a fairly clear horizon, you don't have mountains or buildings or that sort of stuff in the way, you should be able to make it out. And that, Stuart, is the night sky for May.
That's senior science writer and Sky and Telescope magazine contributor Jonathan Alley, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.